All right, so the next, the fifth one here of the describing center is what we call the weighted average. Weighted average. So with a weighted average, here's the equation on the board. We'll talk about what each one means here in a second. But with a weighted average, what we do is we take each, think about it like this. What you're doing here is you're not treating each data point the same. Maybe certain data points have a certain weighted factor. Okay? The weighted factor could be 0 to 1, could be 0 to 100, whatever it is. But you're taking each individual data point and multiplying it by some weight factor. Okay? Meaning you're either giving it more credit or less credit in the overall scheme of things. Okay, so on page 336, I think it's 336, yep. The weighted mean gives the equation at the bottom. Mid-range mean, it gets a little more complicated to find. You can group data, etc., give it a certain weighting factor, whatnot. And so that's what it really translates to. So in this case, again, sun, again, this is your weighted mean. N again is your what? Nick? N is what?
Data points, isn't it?
Yeah, sample size, yep. How many points? X again is each point. F is the weighted factor, the weight factor for that data point. And sigma just means sum it up. Okay, it just means sum it up. Alright, so we'll do an example. What it says, first example it has on page 337 says my X column here. We have 2, 3, 4. So here's our 6, 7, 8, 9, 10. Our factor in this case, 10, 8, 7, 5, 6, 6, 4, 0, 4. Okay, and it was.
Say weight factor for F.
What was that?
Weight factor for F.
Yeah, A firm. All right. So what the math is telling us to do is it says for every X, multiply it by F, and then just add them all up. So here's our first column, second column, and then we need a third column. Third column is X times F or F times X, either choice. So then we just take this times this. So 2 times 10 is 20, 24, 28, 25, 36, 42, 32, 0, and 40.
So it hides in the.
Yep, you just take column 1 and multiply by column 2. So at the top, that's what column 3 is equal to column 1 times column 2. That's what I'm saying at the very top. All right, then the last step is to add up that third column. All right, if you add up that third column, all right. Oh, sorry, my fault. Sorry, my fault. I got this backwards. My fault. The X is the weighted factor for this. My fault. And this is frequencies. Okay, I'm sorry, I got that backwards. So remember how we did frequency distribution last night, Nick? This is how you would find an average in a frequency distribution.
So using this form, right?
This is what you would use, yeah.
Okay.
Remember you have the two columns? First column is the categories,
Yeah,
and then the frequencies. You just multiply the two columns together to get that.
okay.
Okay? So we add up to column 3, we get
247.
247.
According to the book.
Yep. And then if we sum up this column, which is our frequencies, how many data points we have? We have 50. So then the last step is to take 247 divided by 50, which is 4.94 years. All right, any questions with that? It's pretty straightforward. Like I said, we just take one column, multiply it by the second, and then sum up columns 2 and 3. That's all you need to do. Okay. You guys want to do, we'll do one example. How's that sound? So let's skip to page 339. Actually, hell, I'll have you guys do it. Page 339, there's a data set in the center. It says, you have the following data set, 70. The group of 7 students received the following grades on a quiz. What I would like you guys to calculate is these 5 things. Actually, 4 things. There's no weighted average. I want you to calculate mean, median, mode, bin range. You guys can work together. you're gonna talk to Kevin.
You
So I want you
can't-
guys to work together, Nick. Come on!
It's only two of us.
Nick's like, I'm an army of one.
You wrote them out, didn't you? Good for you. Yeah, that's what I got. Yeah, same as you.
Okay.
He's right. He gets a gold star.
Oh, does he? Yay! Good job, Nick.
I've never gotten a gold star in my life.
Of course you have.
No, I haven't.
Okay, maybe it was fake gold, but I'm sure you got one once.
No. I have never gotten a gold star because my school has never believed in that.
I believe you. I believe I can fly too. I believe I can fly.
Aren't you a pilot?
No, we need to. I'm back to. I don't want to offend pilots anywhere. All right.
He's the backseat driver of every situation.
Yeah, exactly.
Hey, do you see that bird?
Yep.
Yeah.
When I try to drive, my husband turns me to the backseat driver. Like he's the backseat driver. Like.
Have you ever just felt like, is that what I'm like when I'm in a plane with someone?
I'm usually kind of quiet until we're just droning, and then that's when I just start talking to people. It gets boring. I'm known for talking a lot. Usually when it's boring, so I get so bored. All right, so we talked about center. All right, so the next part, section 8.3, is now going to focus on the opposite of bringing us together. Is now where are we different? All right, so when we look at the data, we want to see how does all the data, where does it bring us together, where do we have in common? All right. By the way, any questions on that before we move on? I'm sorry. Okay. 8.3, we're going to switch gears and we're going to talk about what's the one thing in statistics everyone hates? Calculating. Oh, sorry. These are always the easier ones, I thought. And then everyone hates calculating standard. That's right. Everyone hates standard deviation.
I mean, I don't have that much of a problem with standard deviation. Just writing everything out.
Yeah, most people hate it because it just gets confusing. It just gets confusing, and then I'm just like, oh God, what do I do? What do I do with my hands, Nick? Tell me, what do I do with my hands?
You move them.
Move them. That's right. I like that.
You
Good.
grab things. with
Sure, don't want to join the army. Just saying.
No, I'm good.
I look at you. I'm good. You just crapped yourself or something.
I was trying not to laugh and say I'm good at the same time.
That's fair.
Not everybody dies in the army.
Well, no, we all die sometime.
All right. So now what we're going to talk about is, like I said, standard deviation. This idea of how much difference is there in a data set? Okay, so let's just play hypotheticals for one quick second. I'm just going to draw a picture here. Think of this line as representing like a number line. So this, sorry, let me back up here. So this dotted line here represents a number line. Okay, maybe it starts down here at 30, goes up to 40, whatever it is. This line here represents the x bar. Okay, what did we say the x bar was?
Say what?
We always said it was the, okay.
Yeah, it's a sample mean. All right, so that means this is, no kidding, we'll say it's, for shits and giggles for this, we'll say it's 35. All right, so that means that x bar is in the center of all the data. All right, the average. So if we look, let's now go back and say that each one of these x's represent our sample. Okay? Now this represents our sample. So meaning each one of these has this is probably like 30, the value is 33, 33 and a half, 44, or sorry, 34, 34 and a half, etc. You see where I'm going with this?
Not very accurate. Tons. Calculation.
Wait, is it accurate or is it precise?
Not accurate.
Is it?
No, because accurate would be, didn't you say accuracy is hitting the target?
Getting closer to the target, yeah.
Some of that one on the way top was way out there. That's not very accurate.
It's probably the answer 37. Is it precise or is it accurate?
I think it's more precise.
Yeah, it's got more precision than accuracy, you're right.
Yeah.
All right. So now let's say, for example, we look at this data point here, and we say, how far off is that data point from the average? So now we're going to look at, so in order to determine how much difference we have in the sample, we need to find a middle point, and we use the average. So then with standard deviation, what we do is we come in and we look at each one of these data points and compare it each one of these we compare to the average. All right, so we take this distance right here. And then we take this distance, and this distance, this distance, this distance, this distance, and take all of those distances and we add it up. All right?
You add up all the numbers where it's placed.
So see this distance right here?
Yeah.
So let's assume that if this is 38, this is 35, what is this distance there? 3, yeah. And each one of these has a numerical value.
Okay.
And so we're adding up that distance,
Right.
okay? And then what we do is we do some more math on it. But when we get done, we get a number that represents the total amount of distance compared to the average for each data point, okay? If a sample, go back to the accuracy statement. Nick, good observation. Meaning, why I say it's a good observation is this. Data points that are spread out further will drive more of a standard deviation. Okay, it's kind of a foot stomp. If you stop and think about it logically. Okay? Meaning that a good data set, a perfect data set, would be damn close to that center line right there, right? But in the real world, it's got that spread, right? If we look at the equation for standard deviation, we'll explain in which each one of them go. One sec. Pretty much means that if, just how mathematics works, if you have a bigger numerator and the denominator stays constant, the answer is going to get bigger.
Is that the equation we always use?
Correct.
Okay.
What I'm trying to get at is, if you have more and more dispersion in the data, your standard deviation is going to increase. Okay? I'll repeat it one more time because this is a foot stomper. And we'll come back and explain what all this means in a second. If you have more dispersion in the data, you will have more standard deviation. All right? Now, I'm going to throw in a second logic piece to that. Okay? More standard deviation from a statistics standpoint is bad.
You want to get as close to the center line.
You want to get standard deviation as small as you can. Okay? Meaning you want to minimize that number as much as possible. If your standard deviation is bigger than your average, you have a shit data set.
Do over.
Do over. Sample's garbage. Start all over again. Okay? That's kind of that's a third foot stomper. If your standard deviation is more or damn close to your average, you got a problem. You have a problem. Houston, we have a problem. Okay? So, go back over those 3 things I just said. What were they, Nick?
The more standard deviation you have, the worse that your target.
Okay, so yeah, we'll go back to the first part. We said the more dispersion in the data means you're gonna have a higher and higher standard deviation.
Mm-hmm.
Okay, that was number 1. Number 2 was now. What were you just saying?
Standard deviation is higher than your average, you got shit data.
Yep. And number 3 would be, again, the more and more standard deviation you have, that's bad. So why I bring this up is I took a graduate level statistics course. I was the only engineer in the class full of statisticians. We're going over this complex thing. I'm so confused. I raise my hand and I go, so what you're saying is a higher answer is bad. As an engineer, you just put terms and things of good and bad. That's what you really need.
Yeah.
Is this good or is it bad? And then class starts laughing. He doesn't know what he's talking about. And I'm like, I just ask it, the professor goes, well, it depends on yada, 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 you know, and I'm like, and then I was like, so is that a yes or no? And he goes, yes, there's that. And I was like, that's all you had to say, man. Okay? But yeah, in this case, you don't want a big standard deviation. Foot stomp, foot stomp, foot stomp. Okay? So let's go back and explain this. S is your standard deviation. Okay? N is not for Nick, it's for
Samples.
sample.
Sample
Sorry, alright? Sigma is what?
Sum it up.
Sum it up, add it up. Alright? X bar again is what?
Still weighted.
No?
No, wait.
Nope. Which
No,
one of these?
the last one was weighted factor, but this one is, isn't the one that you erased, is that the one you're talking about, or is he talking just the
Median?
Oh, my finger started.
Me.
Yeah, let's say my finger started moving. Well, I screwed that one up. Alright, and then X is each point. Alright, so when you write that down, let me know. And I'll go back and I'll just translate what the damn thing is telling you.
Wish that AC was louder.
Happened here now?
Sorry, I was just sitting my sister something. We're working. I came up with a great idea for a Christmas gift for my parents, and my parents they're in their 70s, late 60s, so they're all about you don't have to get us anything. So I've just really been thinking a lot, and then lately I took this idea of I want to interview my parents. I want to sit down and have like 2-3 hour conversations and just ask them questions. Who are they? Where did your name come from? Like, I'm realizing how much I don't know about my parents. Like, who are you? Where are you from? What did they call you when you were a kid? What were your toys when you were a kid? Talk about their childhood, high school life, their careers, their hobbies. Who are they? So that when they're not here, I can, pull something off the shelf someday and go, this is my dad. And then they got grandkids, so that when they're older, they have kids. Well, this is your grandpa Delbert, and he was a minister, and he did this. And here's his recording. Here's all the interviews. And
That's actually very thoughtful.
my sisters were on board, so I told them, I was like, I got to type this up and tell them what my idea is. So sorry, I've been like, that's what I've been focused on today.
See, I tried to do that once. I tried to get someone to know my mom more. She went, why are you being so damn nosy? I was like,
She's like, listen here, kidney stone. That's what she calls me, kidney stone. All right, so let's translate what this is saying. What it's saying is take each individual data point, subtract it from the mean.
Okay.
Okay, so that's this right here.
So,
This 3, right? And then when you get done with that, you're going to square that value. And the reason why they're squaring it is because notice you have some data points to the left of the center. And if you try to add positive and negative numbers together, it doesn't work.
You're not gonna square each individual, you're gonna square the sum of all of them, right?
Nope, you're going to square each individual
Get the
one.
fuck out of here, okay.
This is why people hate standard deviation. All right, now when you get done squaring each one of them, now you're going to add this with this, with this, with the squares of each one, square root it, then divide by n minus 1. Okay, now,
so make sure you do all of the top first and then.
yes, exactly right. And you can do this via table. It's pretty straightforward if you just follow the steps. And even if you have 100 data points, it takes a little time. But if you do it via this table, how they set it up, it's pretty simple.
I can't look at it because my computer's been restarting for this whole entire class.
Whole class?
Yeah, it's
What
just.
do you do?
well,
Did your
no, no, no.
Tumblr crash?
No. What? No. I don't-
Tumblr crash?
What do you mean?
Why are you turning red when I mentioned Tumblr? Huh?
Oh, because it reminds me of my friend Mark.
Huh?
His Tumblr.
No one uses Tumblr except
What
for
is
porn, okay?
That's exactly.
Exactly.
That's exactly. He
Do
showed
you
me
have a
his
Tumblr?
page.
Not a Tumblr?
Yeah,
No.
you don't. Okay, so we know.
Okay.
My friend
What
Mark
the
told
fuck
me.
is Tumblr?
We'll show you after class.
I used to have a Tumblr and then I kind of just like, I deleted
Okay.
Think of a dirtier version of Instagram.
It's and people who
I have
I do
Instagram.
art projects on Tumblr. Shut up. 'Cause you guys
Just
use
make an
Tumblr.
Instagram page, you're fine.
Exactly. All right, so on the top of page 344, all right, it gives us, there's two data sets. I'm just going to pull one of the two data sets. It says 20, actually, or do you guys want a real example?
Which one is more beneficial?
Let's do a real example so you can always go back to it. On page 346, top of the page says, calculate the standard deviation for the following students. Okay? The standard for the following age of students: 25, 21, 37, 18, sounds like our class, 32, 27, 45, and 19.
Why'd you stop?
Because I burped.
Oh,
I was trying to not while I'm talking, please. And it's asking us to do the standard deviation. What I want to do for this problem, okay, we're going to throw in two other things with this. I want you guys real quick to calculate mean, median, mode, and min-range. Okay, so do that first, and then we'll come back and pick up standard deviation. And you guys can compare with each other.
Question. What if there's one that's not frequent?
The mode, you mean?
Yeah.
Then it has no mode.
So just say,
No mode.
just say none.
Nope. There's no mode. That's perfectly possible.
You said the mean, mode, the median, and the mid-range, right?
Yep. Mean, median, mode, min-range.
got the 19, so.
All right.
I can go wider than that 7.
So I want to do two things here first. When I do standard deviation, and we're going to come back to this mean, median, mode thing in a second, I like to put my data in order from min to max. It's not required.
It's just easier
It
for you.
When you start looking at the data, you can find your mistakes way easier because you see it in sequence. Because you can see this. It's like taking all this, and now you start here, the furthest one out over here, and you go, it pretty much is like a line like this. So you can see, oh, I made a mistake there. Okay, so if I start to rearrange this in order, I get 18, 19, 21, 25, 27,
Yep.
32,
Yep.
37, and 45. Okay, now, mean, median, mode, mid-range, what'd you guys get?
Mean 28, median 26,
Okay,
mode none,
no mode, okay,
and then mid-range 31.5.
okay, perfect. Alright, so that's kind of our entering point. So we look at our data and go, okay, our median mid-range, yeah, it's telling me right there that something's pulling the data, right? In one direction. Some of those data points are out in the extremes. Okay, so step one, standard deviation. We're going to take care of the numerator first. Okay? Column one, imagine this right here is what we're going to call column one. Okay? Next column is column two. Column two is x minus x bar. So what you're going to do is take x, so in this case 18 minus 28. 28 was the average, right? You guys said?
Yes, the mean.
I mean, yes, sorry. Okay, which in this case would be negative 10. Next one is 19 minus 28, which is
Also, all you do is you just
all the way down, yep. So this would be negative 9. Oops, there we go, negative 9. Next one is 21 minus 28, which is negative 7. Next one is negative 3. One after that is negative 1. 4, 9, and what is that?
17?
17? Yeah, sorry. It's on my brain for it. Okay, so that's column 2. Column 2 is you're again take the x in the previous row column, and then that's why I had you guys calculate all the center points. Okay? Next column, column 3 says, take column 2 and square it. By the way, so the number inside the parentheses, all that means is the column number. Alright? So negative 10 squared is 100. 9 squared is 81. Negative 7 squared is 49. Negative 3 squared is 9. 1's 16, 81, and I gotta look up 17 squared. So I don't know what it is. And if you're getting different numbers, let me know. Yeah, holy frijoles. Let me know if you guys get the same for column 3.
I got 289 for 17 squared.
What was that again?
289 for 17 squared.
Yep, that's a 9. That looks like a 4, doesn't it? Yeah.
Is there more columns?
That is the last column.
Okay. I was just asking if there was any more.
Oh, okay, that's legit.
So, question,
Yeah.
it might be a calculator question, but when I do negative 10, hit the function key
Yep.
to square it,
Yep.
gives me negative 100. If I just multiply negative 10 times negative 10.
Oh, because what it's saying is negative of 10 squared. So if you go,
And then do the square?
Yep.
Okay.
I don't know why I choose the way the calculator back from Brett, and I don't know how to use it. Okay. Yeah.
Okay, because I trusted your math, but I was like, why does mine say negative 100?
If you have any negative answer in column 3, up there on the board, what is column 3? Yeah, you got issues.
Okay.
Immediately stop. Seesaw actions.
Okay.
Alright. Alright, next step. Next step is take column 3 and add up column 3. And then don't say the number yet until you both have the same number. Or sorry, not until you both have an answer. Then you can compare.
Yep.
626. So that right there, this number right here, represents everything underneath that square root value. Alright, now the next step, you're gonna I'll come over here so you guys can see it. So we set this up, S equals square root of 626 divided by n, how many data points do we have?
8.
8 minus 1. What is the square root of 626? What do you guys get for that?
It's 0.01.
Oh, 25?
So I just said 25.
I think I hit the wrong button.
Whoa.
That's the square root, is it not?
I'm gonna check. They got me checking. That's kidding me.
You can check it out.
Yeah, 25. 25.01
Whatever.
divided by
7.
7. When you divide that out, what do you get?
3.57.
3.57. Very good.
I hit the wrong button for the square root.
Oh, is it under? It should be under the function menu, I think.
Yeah, that's what I thought. I
Right.
did that. 626, right?
Or, that's weird.
It's, okay, so it's just not me. Okay.
Oh.
Yes, just me.
They made this thing too complicated. This thing used to be such an easy calculator.
Yeah, because I hit what I know is a square root button and hit enter and it said 626. What the fuck are you talking about?
Another way you can do square root until you figure out how to do it is take it to the 0.5 power.
Oh,
Square
really?
root. Yep.
That's good to know. I remember that one.
Yep. Yeah, write that down so you don't forget. That's the easy way to skip around that. When you get more into like calc and stuff like that, there's those kind of tricks with math I like. All right. You guys want to see another one?
I think it's pretty straightforward.
Okay. So again, I'll just walk over the steps. So step 1 is determine mean. You have to calculate your mean if they don't give it to you. You have to calculate that. Again, not required, but I think see, because now you can see the data. Because this column right here is telling you this is how much error you have.
Yeah, it's more organized.
Yeah, see how it goes big down to small and back up to big again? If it's more like this, it's just hip-hopping everywhere, you don't know what's going on. Alright? But like this, if you get, like, let's say this was 100, you'd be like, I screwed up somewhere, I need to look at that again. Okay? A lot of error, down to 0, and where was the average at again? 28?
28.
Yeah, that's pretty close. Should be, yeah. Notice how the error looks.
Oh, I see what you're saying.
Yeah.
Okay.
And then when you're done, you sum up column 3. There, that is everything underneath the square root. Come over here, under the square root, divide by n minus 1, and we
So
get our number.
basically, what we did on the columns is the top part already down to just the last.
A firm. Yep. A firm. It's kind of funny. I've never done this in a class before where it's just like last week when I said it just seems so smooth on Friday night. Everything just seems so smooth. Like,
Smooth until I go home and try.
I know. That's why I was sitting here going, do we need to do another one, or it's up to you guys.
I've got good notes here.
Okay.
So.
And if you write that down, good notes, you can duplicate this.
Yeah,
Yeah.
that's exactly what I'm gonna do.
Okay.
Yeah, I just have all the columns written out
Yeah.
from start to finish.
This here's pretty step by step. But, you know, when I was in the Netherlands and I didn't see that one equation. Sad.
Trying to check this here real quick.
Huh.
Let's take 10, and then what we're gonna do is come back and talk about bell curves. We'll set up for tomorrow morning. We'll finish talking about stats, and I'll record it since you can't, again, it'll be all uploaded, discussion, lecture. And then tomorrow we'll finish out with the morning part. We'll talk about z-scores. Z-scores help us correlate on a bell curve how different is my data, if you want. Like, if someone, we'll talk about tomorrow. And then correlation. Correlation's pretty easy. Meaning I have an X, Y, and a scatter plot. What does my data look like? That's pretty straightforward. That's pretty straightforward too. And they don't ask for much you to do in this class. And then tomorrow what we'll also do is the rest of the class, I'm gonna get the example test. And whoever's here, I'll just walk through and do examples. It was me recording myself, then I need someone to show up. So Nick, call Miranda and say, be here. So,
She's grounded, right? You got her in trouble?
that's right. But yeah, take
I didn't mean to. I told her I wanted to